Welcome to the Deep Dive. We're the show that takes complex topics, digs into them, and, well, gives you the core knowledge so you feel genuinely informed. Today, we're heading into a world that's usually invisible, but absolutely essential for modern air travel. Just picture for a second. You're sitting comfortably, maybe watching a movie, cruising way up at 40,000 feet. Outside that window, it's incredibly hostile, a frozen vacuum, basically. Temperatures down to minus 56 Celsius, air so thin you'd pass out in, what, minutes? Seconds even, yet inside you're breathing normally, maybe sipping a coffee, totally unaware of the extreme danger just inches away. Now, how do we pull off this incredible feat? Well, it's all down to a marvel of engineering that often goes unnoticed, the aircraft pressurization system. And our mission today, a proper deep dive into these systems. Now, this is specifically geared towards you if you're in the middle of preparing for your ATPL theory exams, that's the Airline Transport Pilot License. We're going to pull out the really crucial bits of knowledge, highlight the key facts, the figures you need to know, and give you a solid understanding.
Not just to ace those exam questions, but to really get the why and the how behind it all. Our guide for this exploration is based on detailed material from Aircraft Pressurization Systems, Operation and Maintenance, a real cornerstone text in this area. So we often hear about planes flying high for efficiency and needing breathable air inside. But let's start right there. Why do we really need pressurization? Is it just about comfort?
That's the perfect place to start. Because you're right, comfort is a nice side effect, but it's absolutely not the main reason. Not at all. The real core drivers are, well, twofold. They're rooted firmly in fundamental human physiology, how our bodies work, and in the basic operational performance of the aircraft itself. See, when a plane flies really high, let's say above 10,000 feet or so, the air gets incredibly thin, the atmospheric density just plummets. Now that's great for the plane. Less air resistance means much better fuel economy, higher speeds, it's efficient. But for us humans, our bodies just aren't built for that environment, plain and simple. Without creating an artificial atmosphere inside that cabin, flying at those altitudes becomes, well, life-threatening.
Okay, so definitely not just comfort then. This sounds much, much more critical. What are those absolute non-negotiable factors driving this need?
Exactly. It's fundamentally about survival and maintaining human performance. The biggest, most immediate danger at high altitude is hypoxia. And just so we're clear, hypoxia is the medical term for when your body's tissues aren't getting enough oxygen. The effects are serious. They can be subtle at first, insidious, but they get progressively worse. You might start feeling like you can't concentrate quite as well. Now, for a passenger, that might be confusing, but for flight crew making critical decisions, even a slight reduction in concentration can quickly become catastrophic. From there, it rapidly moves to impaired judgment, loss of coordination, and then eventually loss of consciousness. And if nothing changes, ultimately death. Think of your brain being starved of oxygen. It loses its grip. Critical thinking becomes impossible. This isn't just feeling a bit off, it's a silent killer. And historically, sadly, there have been incidents linked to hypoxia in aviation, which really underlines why these pressurization systems are so incredibly vital. Now, let's put some numbers on this because these are absolutely key for your exams. Generally speaking, up to an altitude of around 10,000 feet, the natural air pressure and oxygen levels are okay for most people. We can function reasonably well, but climb much above that and the lack of oxygen becomes very noticeable very quickly. And this is precisely why aircraft cabin pressurization systems are designed very carefully to create and maintain an internal environment equivalent to about 8,000 feet or less. That 8,000-foot figure or lower is a really crucial target. Why that specific level? Because at that pressure altitude, our bodies function effectively. Passengers and crew don't need to be constantly hooked up to oxygen, except obviously for emergency backup. The physiological effects are negligible. It makes long flights possible and thankfully comfortable. And this leads us to some really vital altitude thresholds. You absolutely need to know these for your ATPL studies and exams. While 8,000 feet is the goal, things change if the cabin altitude starts climbing unexpectedly. For instance, if the cabin altitude reaches 10,000 feet, the flight crew must immediately put on their oxygen masks. No question. It's a critical safety procedure. Protects their...
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.